3, 2, 1, and liftoff of Discovery, hoisting harmony to the heavens.
Hello everyone, today we are taking a look at Blue Origin's BE-7 and BE-3 engines. Rockets are comprised of an almost endless list of different parts and components, each serving a specific purpose. Altogether, if done right, they work in harmony, and are capable of propelling thousands of pounds out of Earth's atmosphere and even further. One of the more important parts of a launch vehicle, however, would easily be the engine. These have the job of turning propellant into thrust, and lifting the launch vehicle off the ground, and to its destination. Blue Origin is working on multiple launch vehicles and engines as well. One of these engines is in use on New Shepard, and another is planned to be a next-generation rocket engine. These two engines are the BE3 and BE7. Both are very different in how they are built, used, and their plans for the future. However, they both are similar due to their complexity and purpose. The BE engine series is crucial to Blue Origin for practically all of their operations. Without a high-quality working rocket engine, the company will not be launching any rockets. This includes not only New Shepard, but New Glenn as well. Despite complications with the BE4 engine, the company is continuing to work, develop, and produce a rocket engine capable of future missions and launches. Blue Origin engine background. Currently, Blue Origin has 3 different engines they are either using, or in the process of developing and testing. These engines are all a part of the same family. These 3 engines include the BE3, BE4, and BE7 engines. In addition to these 3 primary engines, in the past Blue Origin worked on previous models including the BE1 and the BE2. As each engine model progressed, they would become more powerful and efficient. This would be through different design changes along with the use of alternate propellants and more. When building this engine's family, Blue Origin had multiple important factors in mind, including reusability. Operationally reusable rockets demand high-performance engines capable of deep throttling for a soft landing. In addition, the engines are built for multiple uses, and Blue Origin mentions their family of engines is powering the next generation of rockets for commercial, civil national security, and human space flight. These Blue engines are designed, developed, and manufactured at Blue Origin's headquarters in Kent, Washington. The company is now preparing for serial production of their most powerful engine, the BE4, in Huntsville, Alabama. This engine is meant to power, not only New Glenn, but United Launch Alliance's upcoming Vulcan Centaur. However, the development and manufacturing of the engine have not gone completely to plan. Lastly, all of the company's engines and propulsion subsystems are thoroughly tested and qualified in Van Horn, Texas. Blue Origin engines. BE7. The first engine Blue Origin is working on, that I want to highlight, is the BE7. There is little information on this engine due to its early stage of development and planned future use. However, we do know the engine is an additively manufactured, high-performance, dual-expander cycle engine. This manages to generate around 40 kN, or 10,000 pounds of thrust. So far, Blue Origin is maturing the design, manufacturing hardware, and has begun hot-firing the engine. Taking a look at its application, the BE7 is meant to be Blue Moon's engine. Blue Moon is a lunar lander meant to sustain a consistent human presence on the moon. The high specific impulse, deep throttling, and restart capabilities of the BE7 make the engine ideal for large lunar payload transport, while enabling Blue Moon's oxygen and hydrogen fuel cell power system. Blue Origin put a lot of work into simplifying and cleaning up the design and plumbing of the BE7 engine. Positioned at the top is the thrust chamber assembly, right under is the hydrogen pump and oxygen pump. Finally, you have the large nozzle assembly at the bottom of the engine. BE3. The next engine I want to highlight is the BE3 engine. In terms of achievements, this engine is the first new liquid hydrogen-fueled rocket engine to be developed for production in America in over a decade. In addition, on the 23rd of November 2015, the BE3 PM powered New Shepard's propulsion modular PM above the Kármán line and reignited for a soft landing on its history-making flight to space and back. That same engine repeated the feat 4 more times before Blue Origin retired the propulsion module. It's important to point out that there are multiple variants of this engine, each with a specific purpose. The first variant is designed for first-stage applications. At full throttle, the BE3 PM generates 490 kN or 110,000 pounds of thrust at sea level. This equates to over 1 million horsepower. When returning to Earth, it uniquely throttles down to only 90 kN or 20,000 pounds of thrust, which enables a gentle and safe vertical landing on the pad. Similar to the Space Shuttle's main engines, the BE3 PM uses high-performing liquid oxygen and liquid hydrogen as propellants. This engine is designed for operation reusability with minimal maintenance between flights. This is very important as launch vehicles such as New Shepard are meant to land, be refurbished, and get prepared for its next flight. The design of an engine can easily practically destroy the entire component after a single launch. Blue Origin worked to avoid this with the BE3 and other engines. The company approach increases availability while lowering operating costs. This engine also features a complex design consisting of an oxygen turbopump, main fuel valve, nozzle assembly fuel turbopump, thrust vector control system, and much more, all of which combine into a single engine helping propel New Shepard to the edge of space. Now that we have looked at the BE3 PM variant, we can shift our focus to the upper stage variant or the BE3U. This variant is the newest member of the BE3 family and is being optimized to operate in the vacuum of space. Specifically, this engine features a back-to-back turbine assembly and a larger nozzle. This helps it generate 710 kN or 160,000 pounds of thrust in a vacuum. In the future, this engine will be responsible for propelling New Glenn's upper stage. Exactly 2 BE3U engines power New Glenn's restartable upper stage, which enables the full range of customer missions including direct injection to geostationary orbit. Building on years of operational experience and rigorous testing, the BE3U is expected to be one of the best understood rocket engines when it launches into space. Taking a look at the design of the engine, it starts with the LO2 and LH2 inlet at the very top of the engine. These feed towards the back-to-back turbine assembly positioned above the thrust chamber assembly and coolant control valve. Lastly, there is the vacuum-optimized nozzle assembly, working to get as much thrust as possible while in space. Conclusion. Right now Blue Origin has its plate full with different projects and goals. This includes New Shepard, New Glenn, a moon lander, and much more. Each of these projects also features additional engines within the BE engine family. Specifically, a lot of work has and is continuing to go into the main three including BE3, 4, and 7. Here I took a closer look at Blue Origin's BE3 and BE7 engines. These are meant to help power not only the lunar lander, but New Shepard and New Glenn in some way, shape or form. While the company is having some complications with other engines such as BE4, we can hope for their success and improvement over time. We will have to wait and see how engine development and manufacturing progresses and the impact it has on the space industry over time. Thank you very much for watching.